Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Today I want us to discuss the nitrogen cycle. As you can see, here we have the cycle of nitrogen, and nitrogen gas is an essential nutrient for plant growth. Therefore, nitrogen gas is not absorbable in its free way. It therefore have to be converted into form of nitrates or ammonium compounds that can be absorbed by the plant. Therefore, there are various ways in which this nitrogen can be converted to other forms which can be absorbed by the plants. As the subtopic suggests, the nitrogen cycle is just about the cycling of nitrogen in the atmosphere, sometimes being absorbed by the plants, transferred to the animals, then animals decay, and finally then released back to the environment. Then the cycle continues like that. If you look at this chart we have here today, this is the free nitrogen, and we can see that we have two ways of converting nitrogen into the form that can be absorbed by the plant. The first way of converting nitrogen gas is by fixation by lightning, or rather fixation by free living. Now, importantly, there are two ways of nitrogen fixation. That is fixation by lightning, and we have fixation by free living. Therefore, nitrogen fixation can be classified into two: nitrogen fixation. That is, we have two ways of fixing nitrogen into the soil. That is, number one, we have biological fixation. Biological fixation. Under biological fixation, nitrogen can be fixed into the soil by two ways again. The first way of fixing nitrogen into the soil is done by free living organisms. Free living organisms. These free living organisms, they include the Azotobacter. Sometimes we can have algae such as the Anabaena. Now, that is the first way. What these organisms do is that they convert the nitrogen into ammonia, that again is converted by other nitrifying bacteria to nitrites and nitrates, and then can be absorbed by the plant. The other way of biological fixation is by saprophytic bacteria, by symbiotic bacteria. Symbiotic bacteria. E.g., an example of the symbiotic bacteria class here is the Rhizobium bacteria. What the Rhizobium bacteria does is that the Rhizobium bacteria fixes free nitrogen and converts into a form that is ammonia and is being absorbed by the plant. Meanwhile, the Rhizobium bacteria gets food from the plant, and this is kind of symbiosis, and that is what we call mutualism, whereby both the plant and the bacteria are benefiting from each other, as opposed to the parasitism, where one is being depended on, while one is benefiting, the other one is not benefiting. But in symbiosis, or rather mutualism, in this case of the symbiotic bacteria, the symbiotic bacteria fixes nitrogen to the plant in a form that the plant can absorb, while the bacteria obtains food and shelter from the plant as well. This is now one among the fixation of nitrogen. Again, we have number two, we have non-biological fixation. This non-biological fixation is enhanced, or rather is brought about by the lightning. During lightning, the free nitrogen gas is being combined with the atmospheric oxygen to form a gas, that is nitrogen 4 oxide gas. This nitrogen 4 oxide gas Now, if we balance this equation, you're going to have here 2. Here you have 2. These are gas, gas, gas. Again, this nitrogen 4 oxide gas is going to combine with the rain, that's the acidic rain, to form 2 acids. That is, it's going to form the nitric 5 acid and it's going to form the nitric 3 acid as well. This is nitrogen gas combining with water to form nitric 3 acid as well nitric 5 acid. Now if you balance this equation, this is a gas, liquid, gas, not AQ and AQ as well. Now again, from there, these acids, they are going to dissociate in water. Now these acids, they are going to dissociate once they are in the soil. Once these acids they fall down as acidic rain into the soil. Once this acidic rain gets into the soil, the acidic rain is going to dissociate. And once the acidic rain dissociates, it's going to dissociate into nitrates and hydrogen ions. Now, these nitrate ions will be absorbed back into the plant, and the plant is going to utilize it. Now, that aside, we have seen that nitrogen fixation is the process by which nitrogen is converted into a form that can be absorbed by the plant. We have 2 ways of nitrogen fixation. We have the biological fixation, we have the non-biological fixation. In biological fixation, it is done by 2, that is by free living and by the symbiotic bacteria. Essentially, the free living and the symbiotic bacteria, they convert the nitrogen into ammonia, then from ammonia, is being converted by the nitrifying bacteria into nitrites and finally nitrates that can be absorbed by the plant. In non-biological fixation, the lightning combines atmospheric nitrogen with oxygen gas to form nitrogen 4 oxide. Now the nitrogen 4 oxide dissolves with the water to form the rainwater to form acidic rain. Now the acidic rain will fall into the ground, and therefore this acidic rain is going to dissociate once in the soil to nitrates and hydrogen ion, and the nitrate ions will be absorbed by the plant roots, and therefore it is utilized. Now from there, we have other things that's called ammonification. Now this was number 1 was nitrogen fixation. Number 2 is called ammonification. Ammonification. Ammonification basically means the process where the dead organisms are being broken down by the saprophytic bacteria or fungi into ammonia. That is, they break down the dead organisms, or rather the waste materials, and they release ammonia into the environment. This ammonia is again being aided and converted to other forms by nitrifying bacteria. Now let's analyze whatever we have here. As you can see here, we have free nitrogen. We have the 2 ways of nitrogen fixation. Number 1, we have fixation by free living, where we said fixation by free living is called the biological fixation. It is done by free living as well, the symbiotic bacteria. We also have nitrogen fixation through lightning. Now, after nitrogen was converted to this form ammonia, it is acted upon by nitrifying bacteria. The nitrifying bacteria here are 1, you have 2 nitrifying bacteria. That is, they change from ammonia to nitrite. They are called nitrosomonas. Here we have, let's say, nitrosomonas. We also have here nitrococcus. Again, this nitrite has to be converted to nitrate by the nitrifying bacteria. Here we have the nitrobacter. This nitrobacter converts the nitrites into nitrates. This is the nitrobacter. Now we can see that they have been converted from free nitrogen through the biological fixation, that is free living as well by the symbiotic bacteria. We also have non-biological fixation, that is the lightning converting combining nitrogen and oxygen gas to form nitrogen 4 oxide. Nitrogen 4 oxide combined with water to forming nitric acid, And therefore, nitric acid, once it gets into the soil, it dissociates nitrates and hydrogen gas. Now, the nitrates is being absorbed by the plant. Now, this nitrates is being absorbed by the plant once in the soil. Now, what the plant does, the plant uses the nitrates to manufacture plant proteins. They absorb nitrates to manufacture plant proteins. Now, and we know proteins are essentially building blocks. The building blocks of proteins is essentially the amino acids. And therefore, this plant is going to absorb the nitrates and they are going to convert into proteins. Now, this plant is either fed directly or indirectly by animals. The animals can directly feed plants, or the animals can as well feed other organisms which have consumed these plants. Now, once these animals have eaten the plant proteins or other animal which have eaten the plants, their proteins, what happens is that these animals, when that protein undergoes the process of digestion, they will not be absorbed as those complex molecules. They will be broken down, and the animals will now, the protein in plants or from the other animals will be digested or absorbed into the ileum in the form of the amino acids, the simpler molecules of proteins. And if you can analyze that the amino acids is made up of a carboxylic group, is also made up of an R group, is also made up of an amino group. Now, if you look in this one, is the structure of an amino acid. The structure of an amino acid, we must have an amino group. This is NH2, the amino group. C double bond, and this one is the carboxylic group, R group as well, and a hydrogen atom. These ones, the nitrogen has only 3 covalent bonds, and this 1, 2, 3, isn't it? That's for chemistry. While the carbon must have 4 valence, 4 covalent bonds. That is 1, 2, 3, 4. And for this one, 1, 2, 3, 4. Maybe you may be wondering why this one we are giving, so that we are trying to balance the covalent bonds found in carbon. And therefore, this is the structure of an amino acid. What we are trying to explain further or in great detail is that these animals, they absorb the proteins from either plants, that is directly or indirectly by organisms which have already fed on the plant. Now, once these proteins are eaten by the plants, by the animals, I mean, these proteins will undergo the process of digestion, and they will be finally broken down into amino acids through the process of digestion. And what you are seeing here is that an amino acid basically composed of the nitrogen, hydrogen, oxygen, carbon as well. Now, finally, when these plants and these animals, they die. What you know is that nothing lives forever, and when these plants and these animals die, they are acted upon by something called the saprophytic bacteria. Now, the saprophytic bacteria and fungi, they break down the dead plants and animals into and releases ammonia. Now, this ammonia again is taken here. Once here, the ammonia is acted upon by the nitrifying bacteria, that is the Nitrosomonas and the Nitrococcus. Also, the nitrates are again acted upon by the Nitrobacter, that is still nitrifying bacteria, to form nitrates. The nitrates is being eaten by the plants, animals, like that. And you know, now again, these nitrates here, you are seeing again, not all the times, the nitrates will be absorbed by the plant. Some nitrates will be reduced. That is, how can we make nitrates back to nitrogen? By removing the oxygen combined in it. That is, and this is done by Pseudomonas denitrificans. This is the bacteria that reduces the nitrates into nitrogen. As you can see that the cycle keeps on repeating itself. Again, the free nitrogen undergoes the same whole process. Now, in summary, what I'm trying to say is that in nitrogen cycle, we have the free nitrogen, and the nitrogen can be fixed in 2 ways. That is the biological fixation as well the non-biological fixation. In biological fixation, we have the free living. We also have the symbiotic bacteria. That is, they do. In an biological fixation, we have the lightning combining atmospheric nitrogen with oxygen to form nitrogen 4 oxide. Nitrogen 4 oxide dissolves in the acid rain to form nitric 5 acid. Now, the nitric 5 acid and the nitric 3 acid, they fall into the soil as acidic rain, and the plants absorb them. And once they're in the soil, they dissociate into nitrates and hydrogen, and the plants absorb the nitrates. These nitrates, again, they are being converted, they are being absorbed by the plants, from the plant to animals. Then animals dead and they are decayed or are decomposed by the saprophytic bacteria and fungi. They release ammonia. Ammonia is being acted upon by the nitrifying bacteria. They from ammonia to nitrates, that is the nitrosomonas and nitrococcus, and from the nitrates to nitrate, that is the nitrobacter. And also you have the denitrifying bacteria that reduces nitrates to nitrates as well, and therefore that is called the Pseudomonas nitrificans. What is some of the importance of this cycle? It avails nitrogen for the plants, that is one, because we can see the cycle keeps on providing nutrients for the plants because the nitrogen is freed up in the atmosphere, and therefore that is importance of the cycle. And again, we have some anaerobic microbes which depend on nitrogen and do not use oxygen. It's also essential for some anaerobic microbes. Now, I wish you all the best and hope you're going to benefit, and more is in the cookie. Thank you very much.